Good morning all of you. Today we shall solve some numericals on inverting amplifier using op-amp. The first numerical, design an inverting amplifier using op-amp with closed loop voltage gain of minus 15. In the previous class we know that there was a formula which we had derived which was something like this. AF is equal to minus RF upon R1, in which RF happened to be the feedback resistance, R1 happened to be the input resistance, where AF had to be the closed loop voltage gain of operational amplifier in inverting mode. So here in the numerical itself they have told us that the amplifier that they have considered is the inverting amplifier. That is why the formula will be AF is equal to minus RF upon R1. But here in the numerical they have given the closed loop voltage gain which is minus 15. Let us write it first. So AF is equal to minus 15, but then the formula is AF is equal to minus RF upon R1. Amongst RF and R1 both of the values are not given, but then if AF is equal to minus RF upon R1, which means it is minus 15 is equal to minus RF upon R1. Both of the negative signs will get cancelled. If the negative signs are getting cancelled, the remaining result will be RF is equal to 15 times R1. So if RF is equal to 15 times R1, RF value and R1 value both are not being given in the numerical. That is why the input resistance can be assumed as 1 kilo ohm. You can assume some value, you can even assume 10 kilo ohms also. But then for the unity sake or for simplification sake, we can consider R1 is equal to 1 kilo ohm. That is why RF becomes equal to 15 kilo ohm. So now that we have solved, we know the value for R1, we know the value for RF. In the numerical we see the word design. Whenever we see the word design, we are supposed to draw the circuit diagram of the concerned amplifier, and we should be writing the values which we have found out. So here is the circuit. In this circuit R1 value is being mentioned, RF value is also mentioned. Now completes the numerical. Let me now go to the next numerical. The next numerical is, for the circuit below, calculate the output voltage for the following input voltages. So here in the previous numerical it was the value for closed loop voltage gain which was mentioned, but here in this numerical there are three different values for VI, or the input voltage is being given, which means if I consider this as some circuit which is being given already, in which the value for VI is being mentioned. Along with the value for VI, there is the value for R1 and RF is also being mentioned. Now let me first write the formula. The formula for any inverting amplifier is AF is equal to minus RF upon R1. So with the value for RF and R1 both being mentioned in the numerical, we can first find the value for AF. So the value for RF is 200 kilo ohm and R1 is 20 kilo ohm. If I put this up in the formula, we will get the answer minus 10. So value for AF which we have obtained now is minus 10. This is unitless because RF and R1 both are same kind of a parameters. Okay, so we do have the formula AF is equal to V0 upon VI, which is equal to minus RF upon R1. This happens to be the formula. AF is the closed loop voltage gain which is equal to output upon input, which is equal to minus RF upon R1. By now substituting the value for RF and R1, we have found out the value for AF. Now in the numerical we can see that the value for input voltage is being given. That is why we can use the formula AF is equal to V0 upon VI as our formula, in which AF value we have found out, VI value is given, we can find the value for V0. So in the first case, value for Vi is equal to 0.2 volts. We know the formula AF is equal to V naught upon Vi. So Vi is given, AF is already found out. So the value for V naught is equal to AF into Vi. So let me now consider the first case. Vi is equal to 0.2 volts. That is why V naught is equal to 10 into 0.2 volts, which is equal to minus 2 volts as V naught. This is the first answer. In the same way, it is being found for the next two cases also. In the next case, it is Vi is equal to 0.5 sine 314t. So in this, you can just ignore the value for sine 314t. That is not at all considered for the simplification sake. We can just multiply the value for 0.5 into minus 10, and that becomes our answer. So V naught is equal to minus 10 into 0.5 sine 314t, in which sine 314t can be ignored. So minus 10 into 0.5 becomes minus 5 sine 314t volts. Likewise, we can just go for third case as well. This is for your assignment, you can do it. Now let us go for the third numerical. For the circuit shown below, calculate the closed loop voltage gain, which means AF value has to be found out. And the second case is given, in which required input voltage to get the output voltage of 2 volts. Which means after finding the closed loop voltage gain, we are supposed to find some input voltage by considering the output voltage as 2 volts. Let us go through it. The previous numerical, they had mentioned the picture already. In this numerical also, they have mentioned the circuit diagram already. In the circuit diagram, when we see Vi value is missing, it is not given. Value for R1 is given, value for RF is given. Let us now calculate the value for AF using RF and R1. We know the formula already. AF will be equal to minus RF upon R1. That is why the answer is, what is the answer given? RF value is 1 mega ohm divided by 20 kilo ohms. So 1 mega ohm divided by 20 kilo ohms, if we do, the answer is minus 50. So minus 50 when we get, we now have the value for AF. Value of output voltage is already being mentioned. So we are now supposed to calculate the value for input voltage. So the formula AF is equal to V naught upon Vi, in which AF value is found out, V naught value is mentioned. So Vi is equal to V naught upon AF is the formula, in which if we put up the values, we will get the answer for Vi. This completes the numericals. You are supposed to write all of these in the notes. And now let us go for the op-amp non-inverting amplifier.